This conference will now be recorded.
If you have a calculator, please take calculator, or in your mobile you can also calculate. So in the last lecture we had seen the methods of calculating the rainfall, right? So one of the method we had seen arithmetic mean method, then Thousand polygon method, and after that there was a method is called as the isohytal method. So in the arithmetic mean method, what we do generally, we take the average of the rainfall, right, in all over the area. Suppose in one area there are the 5 to 6 rain gauge stations, and these rain gauges are showing some readings. So we take that reading and we take the average of these readings, so that we get the rainfall, average rainfall, right? So here we had seen these methods: arithmetic mean method, then Bayesian polygon method we had seen, right? And isohytal method. And we had already seen what is polygon, make it, right? So this is the Bayesian polygon and this is isohytal formula. This is Bayesian polygon formula, right? Then we had solved one problem, numerical also. So today we will solve one more problem. The problem is this one, right? Just I will copy it and I will take here. Okay, now I will read this problem and then we will try to solve this. So here I will read this problem. A catchment area is in the form of regular hexagon. Regular hexagon. Hexagon means which a shape which has the 6 sided of same sizes, right? 6 sided of same sizes. So hexagon of 4 kilometer means each side is of 4 kilometer. 7 rain gauge stations are located at seven rain gauge stations are located, one at each corner and one at center. Recorded precipitations are these 10, 20, 30, 40, 50, 60, and 70 centimeter. Use Thousand polygon method. Now the method is cleared. You have to calculate the P average using the Thousand polygon method. This is the method. Determine the average precipitation. Now we will try to understand what is this problem. See, it is saying that this is the hexagon of just hexagon means this 1, 2, 3, 4, 5, 6 sideds are given, right? This is my hexagon, and each side is of, say, it is said that it is of 4 kilometer. This is say 4 kilometer. Similarly, this is 4 kilometer. This one is also 4 kilometer. This side is of also 4 kilometer. This is also 4 kilometer, and this one is also 4 kilometer. And at each station, so this is one of the station, this is another station, this is third one, this is fourth, fifth, right? And this one is sixth one. I will just give the name of rain gauge station 1, 2, 3, 4, and 5, right? And each rain gauge station rainfall is given. Suppose this for one first rain gauge rainfall is say 10 centimeter, right? For this second rain gauge station, this is 20 centimeter. And likewise, this is 30 centimeter, this is 40 centimeter in rainfall. This is 50 centimeter rainfall. This is 60 centimeter rainfall. And the last one is given as 70 centimeter. And that 70 centimeter rain gauge is situated exactly at center. So here that rainfall is 70 centimeter, right? Now, once it is clear, we have to find what would be the average rainfall. So here we have to use the Thiessen polygon method. So the method of Thiessen polygon method is first procedure is join all the rain gauge stations. Suppose this is rain gauge station first, this is second, third, fourth, fifth, sixth, and this is seventh one. So we join all the rain gauge stations. See, 1 to 7th rain gauge station, then this one, then this one we will join. Here we will join this one, like, right. Now the method of making the Thiessen polygon is that we make some perpendicular distance. Okay, here I will make this diagram some more clear and more. Okay, first here I will do, then we will make some more big diagram. So what is the procedure? We take perpendicular bisector to each sides, right? This is one of the side, right? Here I will mark this perpendicular bisector. Similarly, on this is also one of the sides. So here I will take one perpendicular bisector and it will come in both the triangle, here and here, both, right? So this perpendicular bisector will come in this triangle also and this triangle also, right? Now, and this perpendicular bisector will also come and it will come exactly at center. Similarly, for side this second and seventh, I will mark one more perpendicular bisector and it will come into this triangle, this one triangle, right? Similarly, I will mark perpendicular bisector here and it will join here. Similarly, I will mark perpendicular bisector here and here also, and at this. And how up to how long I will come? This will come up to here when this will join. Similarly, on this side, it will this perpendicular bisector will come and it will come into this triangle. So here this perpendicular bisector will meet here, and likewise we will make this, right? Here perpendicular bisector will come like this, and this perpendicular bisector will meet like. Now this is okay to you? Now after that, see, after that, once we completed this procedure, we know that whatever the rainfall will, suppose this is my rain gauge station 1. So the rainfall at rain gauge station 1 is 10 centimeter. This is 10 centimeter. So this 10 centimeter rainfall shows the rainfall of this area only, up to this area, right? Up to this area. Similarly, the rainfall at station 2 shows the rainfall in this area. Is it okay what I'm saying? And likewise, so rainfall at station 2 is showing the rainfall of this area, right? So just I will say that this is my, say, I will say this is, say, area 1, right? And I say this is, say, area 2. Similarly, see, this one will be what? This one will be third area, right? This one will be area 3, and likewise this one will be the area A4. This one will be the area A5. This one, right? This one will be A5. Similarly, this one will be my area A7, sorry, A6, and the center area, this one, this whole area, this one, this area, this one will be A7. Up to here it is clear to all of you? Yes, it is how we mark this. Okay, now see, but see, we want to know what would be this area, how we will calculate this area. So if again I will draw the diagram, it will look like this, right? And this is our, here exactly at center there is rain gauge station. Now here we have drawn perpendicular bisector also, right? If you will see, every side is, each side is a 4 kilometer, 4 kilometer, 4 kilometer. This is also 4 kilometer. This is our perpendicular, this is our bisector, right? This is bisector. Now, and this is also 4 kilometer, this is also 4 kilometer. And see, suppose I take only this one. If I take only this one, this triangle, so if I will be able to calculate the area of this triangle, so we can the other area will be same, like this one, this, every area will be same, right? So this is my which one? The bottom one, right? Now I I will take it outside. This area will be like this, right? And this is 4 kilometer. This is also 4 kilometer. This is also 4 kilometer, right? What I will do for calculating the area of this triangle, I will mark one. I will mark as a. I will bisect. I will bisect and I will break this into two pieces. Now see here. This will be exactly perpendicular. So if this is 4 kilometer, if this is 4 kilometer, can you tell me how much will be this one? If it is exactly bisect to this, how much it will be? Can anyone tell me how much it will be? The this portion. If I, yes, 2, correct. This will be 2. If I say this is A, this is say B, this is C. So this one is, I will say this is A dash. Okay. Here I will say this is A, right? A dash. This is 2 kilometer, and this one will be also 2 kilometer. Now we know that if this is the triangle, so the triangle has all angle of 60 degree, 60, because of all sides are equal. So this one will be 60 degree. This one will be also, means this whole will be 60 degree, and this one will be also 60 degree. And I have to calculate this height A dash. So what I will do? I simply, what I will do? I will do what I will do? I will separate this angle, this one. I add this is A, this is A dash, right? And this is a C, this is 60 degree, right? And this is 2 kilometer. So what would be this height? So simply I will apply the formula tan 60. Tan theta is equal to what? We know that tan equal to what? Muqabil upon, right? Yes or no? Opposite upon adjacent. So here tan 60, apply tan and 60 degree into muqabil is, we don't know, that I say that is h, divided by muttasil means 2 kilometers. So I will say this is 2. So here what would be this h value? H value will be equal to this 2 into tan 60, right? So can you tell me what would be the answer? Can you tell me what would be the answer? If you will multiply tan 60 with 2, what would be the answer? Tan 60 multiplied by 2, 3.46 right? So here we will get 3.464. It means the height is how much? This height is 3 point, height is 3.464. And what would be the unit? Kilometer. Now, once I know this height, this, so I can find out the area of this one triangle. Yes or no? If I know this is the triangle, my triangle, this is 4 kilometer, right? This is also my 4 kilometer. This is also 4 kilometer, and I also know the height is how much? 3.464, right? 3.464. So I will know that what would be the area of triangle. Area of triangle will be how much? This is my A, this is my B, this is my C, right? So area of triangle ABC will be how much? Can anyone tell me? Base into half base into height, and half base is how much? Base is 4 kilometer. This is 4 kilometer, right? So 2 into 4 into height is how much? 3.464. This is 464, right? This is 464. Can you tell me what would be the area? Yes, 6.928. Correct. 6.928. 6.928 kilometer square, right? 6.928 kilometer square area. Now you come to this, again you come to this point. So see here, this is our triangle, this one, right? Yellow one. Again, see, this is divided into three equal parts. One, this, second one, this, third one is this one. So it means if I divide it, see, this is my triangle, and this triangle is divided into three equal parts like this. So if I will divide the whole area, I will get the 1/3 of what is this area. So this area will be 1/3 of my this area. That is what? 6.928, right? How much will be the answer? How much will be the answer if I will divide? Means what? This only this area. This is this shaded area. This shaded area I will get 3.309. Is it okay? Yes or no? Are you getting same answer? Yes, 2.309. Now, this is the one single area, single. This is only shaded. This one. Yes. Now, what I told you, this see here. Now you observe this. Once again, I will tell you. This is my. I will clear it again. But just remember, this is 2.30. Now, this is my actually hexagon, and this is my center. And we know that, see, we know that now we know that whatever the rainfall is occurring at this station, suppose this is my station, this is one station, right? Whatever the rainfall is occurring, that rainfall represents the a rainfall of this area, right? This area, right? And if you will now, one, I will ask you what would be this area, because I know that the 1/3 area of how much, that is 2.30. This is one area, and this is also how much? This will be how much? This one will be how much? If this is 2.309, then this one will be how much? What would be this area? Same, correct, exactly correct. Very good. This one will be also 2.309. Now see here. So how many areas are there from A1 to A7? There are the 7 areas, right? So A1 will be same, will be equal to A2, will be equal to A3, right? Will be equal to A4, right? Will be equal to A5, will be equal to A6. But this seventh area, this one, how much will be this area? Can anyone tell me this area will be how much? Anyone, what would be the A7th area? Yes, anyone? Just think about, and can anyone tell me Mira or anyone? Zayed, Mira, Saif, Shama. What would be this area? Correct. 13.85. Why? Because see, this is the one area. This is 2 second, then 3, 4 one, this one, fifth one, this one, and this is sixth one, right? If I will, you will see this. See, there are the sixth one, two, this is three, this one is fourth one, this one is five, and this one is six. So if I will multiply this one single piece, that is 2.309 into 6 into 6 into 6, I will get the area is equal to what? 13.856, right? 13.85. Now, and A1, A2, A3, A4, A5, and A6 is equal to how much? A6 is equal to how much? They are equal to, see, 2.3 plus 2.309 plus 2.309, right? So I can say that 2 into 2.309. So how much it will be this one? 2.309 into 2. How much it will be? 4.618. Are you getting same answer? Yes, 4.618. So this is from area A1 to A6, and A7 is how much? That is 13.85. Now, the same calculation is given here. So here we have calculated what height we calculated, then we calculated area of triangle, then we calculated one third of area, that is 2.309, right? Now we made, here we have made this station A, B, C, and D, and whatever the area is coming under the station A, that is 2.309 plus 2.309, that is 4.6. And this area will be how much? 4.6 for 1, 2, 3, 4, 5, and for sixth area, right? And the seventh area will be 13.85. Now for the station A, the rainfall is say 10. For station B is 20. For station C is 30. For D is 40. E is 50, and for F is 60, and for the center station is 70. Now, what is the formula for Thyssen polygon? We know that the for the Thyssen polygon formula, P average will be equal to how much? P average is equal to P1 A1 plus P2 A2 plus P3 A3 plus P4 A4 plus P5 A5 plus P6 A6 plus P7 P7 into A7, and divided by this whole, divided by A1 plus A2 plus A3 plus A4 plus A5 plus A6, right? Plus A7. So when I will divide it, I will get the P average using the Thyssen polygon. So here the calculation is same. If you will see, first precipitation is written, that is P1, P2, P3, P4, P5, and what is this? A1, A1, A2, A3, A4, A5, A6, A7, and this whole area is some that is summed. This whole area has added, and here you can see A into P. This is the same. Whatever we are doing. Suppose this P1 is how much? That is say 10 into our area is how much? This area is 4.618. 4.618 plus this P2 will be how much? 20. I think it is clear to you. 20 into this again 4.618 plus then this one will be 30 into 4.618 plus 40 into 4.618 plus 50 into 4.618 plus 60 into 4.618 plus 70 into what is that area? 13 point, what was that area? 13.8485. Then divided by A1 plus A2 plus A3 plus A4 means 4.618 is how for how much time? 4.618 is how for how much time? A 1, 2, 3, 4, 5, 6 time, right? Because there are total 7 areas. So multiplied by 6, I am doing directly, right? Multiplied by 6 plus 13.854 into this is only one area into 1. Now when you will calculate, you will get the P average. Is it okay? All of you, is it okay? How it is coming? This concept is clear? Okay. Now the same calculation is given here. See here, same calculation is given. When this P1 into A1 plus P2 into A2 plus P3 into A3 is completed, see here when it will be completed, when this term, this whole term, when this whole term will be completed, we will get how much? We will get 19.3956, and it will be divided by this total area, that is A1 plus A2 plus A3 plus A4 plus A5 plus A6 plus A7, so that we will get the average rainfall. Is it okay to all of you? This problem is clear to all of you? Yes or no? This problem is clear? Yes or no? Is it clear to you? Okay. Now, another is one more problem is given. Just wait 1 minute, then I will discuss. So just all of you read once the problem. Okay, we will read one problem. Once again, the problem: a catchment area in the form of equilateral triangle having sides 4 kilometer. Equilateral triangle means it is the triangle which is having the same sides or same angle, right? So sides are given as 5 kilometer. So each side is of 5 kilometer. This is also 5 kilometer, and this one is also 5 kilometer. With 3 rain gauge station means here is one rain gauge station. This is I say rain gauge station 1. Here the rain gauge station is 2, and here the rain gauge station is say 3, right? At the corner, the rainfall recorded is given as say suppose at this is what is this? This is 15 centimeter rainfall is here. 12 centimeter rainfall is recorded at station 2, and 10 centimeter rainfall is recorded at the station 3, right? Now these are the rainfall recorded. Find out the average precipitation means in this area, in this whole area, what would be the average precipitation? We have to find using Thiessen polygon method. This is the method. Method will be always given. You find the Thiessen polygon method. You find the average precipitation using Thiessen polygon method or arithmetic mean method or isohytal method. So here the Thiessen polygon method is given means, see what we will do. First of all, we will draw one bisector to this. Another we will draw the bisector to this, and again we will draw the bisector. Now whatever the rainfall is occurring in this area, so it will be represented by this rain station. Another, whatever the rainfall will come in this area, right? That will be represented by, see this is our area, this is another area, and this one is our third one area, this one. So whatever the rainfall will come, suppose this 15 centimeter will represent here. So we have to find using Thiessen polygon method. So what we will do, first of all, we have to find what would be this area. I say this is A1, and this is say I2, A2, and I say this is say A3. So what would be A1, A2, A3? Before finding out the A1, A2, A3, this is same. We have to find what would be the area of this triangle. I say this is A, this is B, and this is C. And what I will do, I will draw one perpendicular to this. I will say this is A dash. Now tell me if this is 5 kilometer, if this is 5 kilometer and perpendicular bisector is drawn onto this BC, what would be this distance? This will be half. Yes, this will be half. This will be 2.5 kilometer. And similarly it will be 2.5 kilometer. Now what I will do, I know that, see if it is equilateral triangle, this is 60 degree, this is 60 degree, and this is also 60 degree, right? And what I will do, I will apply the same formula. Tan theta is equal to how much? Tan 60 is equal to opposite, that is height. Opposite means this AA dash, right? AA dash is divided by um, this one, right? That is 2.5. So if I will calculate what I will get AA dash, can anyone tell me? AA dash will be equal to what? Tan 60 into 2.5. Tan 60 into 2.5. So what would be the height? What would be the height of this triangle? Tan 60 into 2.5. Yes, 4.33. Correct. Very good. So it will be 4.33. So we know that the height is 4.33 kilometer. Now, once we know that the height, we know that the base, so we will find the area of triangle ABC. What would be the area of triangle ABC? Triangle ABC area will be how much? Area will be half base into height. Now half base is how much? Base is 5 kilometer. Yes, this is base is the 5 kilometer. This one height we have find out, that is 4.33. So base will be 5 multiplied by 4.33. Can anyone tell me what would be the area? What would be the area of triangle? half base into height. This one will be 10.825, correct? 825 kilometer square. Now, so this is the whole area, but I am interested only the 1/3 area of this. So what would be this 1/3 area of this? So I will divide it by 3, 1/3. So I will get the 1/3 area. So 1/3 area will be how much? 1/3 area will be how much? That is 10.825 divided by 3. So I will get the 1/3 area. What would be this 1/3 area? 3.608, correct. 3.608. 3.608 kilometer square. Now we know that, see, we know that now this area is 3.608. Similarly, this area is same and this one is the same. Apply the formula, Thiessen polygon formula, P1 into A1 plus P2 into A2 plus P3 into A3 divided by total area, that is A1 plus A2 plus A3. So can you calculate? Because see here, we will see here. Okay. Now see here, we have already find out this is what 10.8 to 1/3 is 3.60. Now simply just rainfall at these are the rainfall 15, 12 and 10 centimeter, right? So here this 15 into multiplied by the area, then 12 multiplied by the area, and they all are summed then. Then this is multiplied by this and it is divided by total area 10.825. So we will get the P average. Is it okay? This is okay to all of you? This problem is clear to all of you? Yes. Now after that there is another method, that is isoheital method. Isoheital method is what? The method it shows that it is very accurate method and it can be used for very large area. So here, see here, you will see this is the total area, this green portion, and this is, you can see these are the contours of rainfall. Means this is the line which is showing the same rainfall, right? And again, this is the contour line which is showing the 4 centimeter rainfall. And between 3 centimeter to 4 centimeter, this is the area, right? This area is how much? We will see later. So this is the one of the area I will, and before that there is one area here you can see. So this is, I will say this is A1, this is A2, right? Sorry, this is A2, this is A3. Likewise, this one will be A4, this one will be A5, this one will be A6, and this one will be A7, right? So once we know that, the formula for, we know this, the isoheital map shows what it shows. Here I will delete this. Now isoheital map shows what is, see, this is our this is contours, right? This is are the contours. So according to the isoheital map, see, this is, suppose this is 3 centimeter contour of 3 centimeter isoheital, this is 4 centimeter isoheital. So what we do, and suppose before that there is a, suppose 2.5 centimeter contour. So isoheital map, according to isoheital formula, what we take, P average is equal to P1 plus P2, right? Divided by 2, we will take the average of rainfall, right? And multiplied by the area which is coming inside, say that is A1, right? This is the formula actually. We have already seen this. This is the formula. P1 plus P2 divided by 2 plus into A1 plus P2 up to so on and divided by total area. right? Divided by the total area A1 plus A2 plus A3 plus A4 likewise. So same thing we will apply here, same formula. So here the area, can you tell me? See here, you will ask one doubt that before this area. See here the area is given, but before 3 centimeter there is no contour. So we can assume that this contour is say this is 3 centimeter contour, this is 4, 5, 6, and this is 7 centimeter contour, and this one is 8 centimeter contour. So we can assume this as a say less than 3 centimeter, that is say 2.5 centimeter, right? So we will take the average of 2.5 plus 3 divided by 2 multiplied by this area. This area means this one, this area, right? So that will be, I will say that is A1. So likewise I will calculate by using that formula, and I will find out the average rainfall. So here see, first you have seen the contour, then in the second slide, see here the area is also given. This is say 20 kilometer square, this is 38, 32, this is 30, 43, 54, and this is 40, and last one is 6 square kilometer, right? Now I will apply the formula. So what would be that formula? See, this is less than 3. Less than 3 means I can take the average of 2.5 plus 3, that is 2.5 plus 3 divided by 2. So when I will do it, so I will get the value of 2.75, right? So here just you can see that it is less than 3. That is the average isohydral. Average isohydral means before 3 there is something that is less than 3. Then if you will take 3 plus 4 divide by 2, you will get 3.5. Then you will get 4 plus 5 divide by 2, you will get 4.5. Likewise 5 plus 6 divide by 2, you will get 5.5. Then 6 plus 7, you will get 6.5. Then 7 plus 8, you will get 7.5. And there is no greater than 8, so we will consider it as a greater than 8. So 8 plus whatever it is, we will just assume it as a greater than 8. Then what we will do, we know that this area is 20, this is 38, 32, 43, 54, this is 40, and this last one is 6 kilometer square. So you can see here the average rainfall is multiplied by the area A1, so we will get this value. Likewise we will calculate all, and we will sum this value. The formula is this one: P1 plus P2 divided by 2 multiplied by A1, right? Plus up to what we will go, up to we will go, this is what last one is 1 2 3 4 5 6 7, right? So means P7, not 7, sorry, this is so we have almost 1 2 3 1 2 3 1 2 3 4 5 6 7, right? 7 means we will go up to P7 plus P8. Likewise P, this is a P2 plus P3 divide by 2 into A2 plus P3 plus P4, then P4 plus P5, then P5 plus P6, P6 plus P7, and P7 plus P8 divided by 2, right? And multiplied by the last area, right? That is say 8, A8. Similarly, and we will divide it by A1 plus A2 plus A3 plus up to A8, right? So that we will get the rainfall average, P average. Is it okay? This method is okay? Is it clear, this method? So for this problem, actually, the map will be given, or otherwise the values will be given. So like the average of isohydral is this one, and the area under comes under this. See, one table will be given to you, right? Here, likewise, and here it will be said that the range of rainfall is given, that is 2.5 to 3, then 3 to, I just say this is 2, and here it is, the range is 3 to 4, then 4 to 5, then 5 to 6, 5 to 6. What are these? These are what? These are isoheightal. These are isoheights. These are isoheights. Then 6 to 7, and then 7 to 8. So these are the isoheights, and under these isoheights, see, this is my area. This is isoheights. 1, 2. This is 2. This is 3. This is 4. This is 5. Likewise, right? And under the isoheights, suppose this is between 2 to 3. This is the area. This one is the area. So this area will be given here. Suppose this area will be given. Say A1 will be, say, 10 kilometer, then 10 kilometer square, then 20 kilometer square, right? Then 30 kilometer square, then suppose 40 kilometer square. So sometimes if figure is not given, it will be given. Then 50 kilometer square, then 60 kilometer square. It will be given like this, and it will be asked that find out the p average. So you have to apply the formula and you have to find this p average. Is it okay? Is it okay to you? Is it okay? Now, so here this is chapter 1 is over, right? This chapter 1 is over. Now we will come to the chapter 2. That is infiltration. See here, we have already seen, this is our chapter. This is not chapter unit 3, actually this is unit 2. We can say chapter 2, right? Just I can say that this is my, this is not chapter 3, right? This is chapter 2. Okay. So here what happens, we have seen the hydrological cycle. Rainfall occurs. Once this rainfall occurs, what happens? This rainfall goes into the soil, right? This is my soil. This is my soil, and this water goes into the soil, and this phenomena is called as infiltration, right? So if it is less infiltration in non-porous soil and rock, suppose here it is some rock is this one, suppose. So water will not go inside, right? But if it is a soil, water will go inside. And when it goes very in depth, then it is called as, we can say, percolation, right? So we had seen already in the hydrologic cycle. Now this was only one term. What is infiltration is clear. When water comes and it goes into the soil, then it is called as infiltration, right? So when precipitation occurs, at the initial, what happens, water goes into the soil, right, into the soil, and after this soil is saturated, this whole soil is saturated, means when this will be filled with total water, this whole soil will be filled with total water, then what happens, then after that this runoff starts. So runoff is also one of the chapter, but here we are going to study about the infiltration. Is it okay? Infiltration is what? Infiltration is the process, we can say, it is the process of water, the soil. It is the process of water entering into the soil. Now, here the definition is given. The process of entering the water into the soil strata of earth is called as infiltration. What I told you, when water goes into the depth, right? See, if this is the soil, right? When rainfall occurs, what water goes into the soil, right? Into the soil strata, and somewhere here you will see there is the groundwater table. Groundwater table means from this ground we get the water. So it meets to the water table. This is water table. So this is the process of infiltration. This is called as infiltration. This is called as infiltration. The process of water entering into the soil is called as infiltration. Now, next is the infiltrated water first meets to the soil. Moisture deficiency means if the dry soil is there, then it will it will wet the soil. Then if any excess water moves vertically downward and it reaches to the groundwater, then it is called as percolation. What I told you, the infiltration is when water is coming just up to this suppose bone, right? But when water goes in very depth and it meets to the water table, then this process is called as percolation. Then this process is called as percolation. This is the definition. Now, what is the next slide? Now here, infiltration capacity. What is infiltration capacity? The infiltration capacity of soil is defined as the maximum rate at which it is capable of absorbing the water, and it is denoted by F. Maximum absorbing capacity, maximum rate at which the water is absorbed by the soil is called as the infiltration capacity. For example, I will give one example. One person is he takes water, one glass water in say 1 minute. He can drink water in 1 minute, and one person drinks the water 1 liter, we can say one or two glass of water in 1 minute, right? So this is the infiltration capacity of that person, right? So one person can drink water in 1 minute in one glass, but another person is the person who takes two glass of water in 1 minute. Means the infiltration rate of that person is 2 glass per minute, right? So that is the maximum. Which one will be the maximum? The maximum will be the 2 glass per minutes. Similarly, if water is coming or rainfall happens, so water goes into the soil. So if it is infiltrating, say 1 meter per second, just I will tell you. So this is my soil, right? When rainfall happens, so what happens? This water will come into the depth. So here, suppose this water is coming here like this, right? And suppose it came here up to here. This came here in 1 second, or we can say in 1 day. So this water drop came at a depth of 1 meter. This is my depth is say one meter, and this water came 1 meter in 1 day, right? 1 day. So the infiltration rate or infiltration capacity is how much? 1 meter per day for this soil, right? Suppose whatever the soil is here available, whatever the soil is available here. So this is the soil, suppose. So in this area, the soil in this area and in the soil, water enters at 1 meter depth in 1 day. So that's capacity, infiltration capacity is 1 meter per day, right? But generally it is measured in 1 meter, not meter, but 1 mm per second or 1 mm per hour, like this, right? We will see that. Is it clear what is infiltration capacity? Is it okay? Now, so here one condition is given, that see rainfall, if I is greater than F, means rainfall is greater than rainfall rate, right? And F is what? F is the infiltration capacity. So simple, if equal to F, term F is, so then F will be equal to F, and it depends. But if I is less than F, means whatever the rate is there, if it is less than the filtration capacity, generally this absorbing capacity is denoted by F. Remember, this is the absorbing capacity of a soil represented by F. Just wait. See here, what he's saying, going to say that this is my soil, and rainfall is occurring here. This rainfall rate is given here, I. This I. Suppose this I is rainfall is coming with the rate is say 10 mm. Per second. In 1 second, 10 rainfall is now. Capacity of soil F, small f, is equal to, say, if it is say the capacity 5 per second. Is it okay? My voice is okay? Now it is okay, Mira? Yes, my voice is now okay. Okay. So here, see here, rainfall is coming with 10 per second, but soil is accepting this water only 5 per second. Means what? Remaining 5 will flow onto the surface. It means the rate of rainfall is more than the rate of accepting, or the rate of infiltration. So what will happen? Runoff will occur. Runoff means the remaining water will flow on the surface, and it will meet to the somewhere on the river or somewhere on the sea. But if this is, suppose rainfall is coming with the intensity, this is my soil. But if the rainfall is coming with 5 second, right? And the soil capacity, this, right? and the soil capacity, infiltration capacity is say 10 mm per second. 10 mm per second means the capacity of accepting or absorbing the water of soil is more. Means what will happen? Whatever the rainfall will come on the soil, the whole 5 mm inside the soil, and no runoff will happen, right? So in this case, what happened with this? So the concept is that it is saying that if I is less than f, if I is less than f, then what will happen? Then fa is equal to I. Means just try to understand. Here it will be given to you. See, if I is greater than f means runoff occurs. If I is less than f means no runoff will occur. Is it okay? This point is okay? Means whatever the 5 mm came, the whole, whatever the 5 mm rainfall, 5 mm absorbed by the soil, means there is no runoff. There is no runoff. But if it is reverse, means 10 mm rainfall intensity and 5 mm absorbing capacity, it means what? The remaining will be flow. Remaining 5 mm will be flow on the earth surface. Is it okay? This is clear? Now the condition is given that if I is equal to f, then fa will be equal to f. But if I is less than f, then fa will be equal to I. So just remember this. The concept you understand. Only concept you should be understand. Now here the another point is that if dry soil is there, then what will happen? This infiltrator means means already in the soil water is available. Soil is there, already is available there. Then what will happen? Then infiltration will be less. So for very dry soil, infiltration will be more. For that is another point. Capacity means the same thing. Suppose this is my soil and rainfall is occurring. Rainfall is occurring. So if in 1 second, just here. So in 1 second or in 1 hour, suppose in 1 hour, how much quantity of water entering into the soil? If it is maximum, it can what be accepted in a particular hour or in a particular second, then that will be called as the maximum capacity. For example, I say that there are the two types of soil. This is soil 1, this is soil 2, right? And in this soil, here in this soil, the rate of infiltration means water travels from this is rate of infiltration means water is coming inside like here, right? So this rate of infiltration is say I say that say this is 5 meter per second. Means water comes inside up to 5 meter only in 1 second, right? And here in the soil 2, soil 1, water is coming inside the in 3 meter per second. Means water, see, this is water is coming right here, and here it came up to here. So in this soil, water is coming with the rate of 3 meter per second, and in the soil 2, water is coming with the help of with 5 meter per second. Means the infiltration capacity of soil 2 is more than the soil 1, right? Than the soil 1. Is it okay? Yes or no? Yes. So this is called as the infiltration capacity. So the maximum rate of water absorption by the soil will be called as infiltration capacity. Now what is the maximum capacity? Maximum capacity means this is talking in terms of volume. See, remember that, remember this point. This is maximum rate, right? This is maximum rate, and here it is maximum capacity, for maximum capacity of absorbing the water by the soil. For example, there are two students. One student can drink water in one day, say 10 glass. Another student is there, he can take the water, suppose 20 glass in one day. So the maximum capacity of the student is what? The 20. I will consider the 20 glass drinking water in one day is the maximum capacity of the student, right? So the same thing is what this is, maximum capacity of water absorbing the soil. Means one soil, how much water can be absorbed by a soil, right? So how much quantity of water can be absorbed by the soil in a day or in a second or in a hour, that will be called as capacity. Capacity means, suppose this is the soil, below the this is the soil, and below the soil how much quantity of water is collected. Suppose here there may be some this is some stone will be there, and within that stone there will be the some porous, and within that porous there will be the water, right? So that is called as the capacity, right? This is called as the capacity of water absorption. Now another point is infiltration rate. Now here the same thing is given, the rate at which the soil is able to absorb the rainfall or irrigation is called as infiltration rate. Generally it is used measured in mm per hour or inches per hour, right? Now another is that, but just to think that how you can measure the infiltration rate. For example, I'm telling you that this is this is the earth surface, and water is going inside, and a person is here, right? But we cannot see below the ground, we cannot see below the ground how water is traveling. Is it okay? My point is okay. We cannot see with our eyes, then how we will find that water has traveled at say 1 meter below the soil surface? How we will find this? My point is, how we will find? We cannot see below the surface of the earth, then how we will find? So for finding that, we have some instruments. So that instrument is called as infiltrometer. So is it okay? You can use this instrument to measure the infiltration. So here, if I means what? Rainfall is greater than the infiltration, then runoff occurs. If it is reverse, then what will happen? Then absorption will be happen. Next is infiltration rate is connected to the hydraulic conductivity. Means how much hydraulic conductivity. Hydraulic conductivity means how much quantity of water in 1 second. That is called as hydraulic conductivity. And hydraulic conductivity is the ability of a fluid to flow through a porous medium. It is determined by the size and shape of the pore space in the medium and viscosity of fluid. For example, you will see here, it is expressed as they see here, you can see that how much volume, how much quantity of water in a unit time, that will be called as the hydraulic conductivity. And what is infiltration? How much water is traveled in depth in 1 second. And what is conductivity? It's a quantity of water in a unit time. And what is infiltration? Traveled by the water in a unit time. Is it okay? The difference is okay? And this hydraulic conductivity depends on the shape of the porous, shape of the pore spaces. Means the spaces will be available below the surface. and if it is more means more hydraulic conductivity. If it is less means if it is the stone below the surface, there is a whole stone is there, so stone cannot absorb the water, that will be hydraulic conductivity weakness, right? Now here some factors are there which affect calculation. So here we will see in the next class, right? And be remember that next in the next week, coming week, we will have a quiz too, right? We will have a quiz too. So here I stop my